So far, we've exclusively been using Lewis structures anytime we've tried to describe bonding within molecules. Lewis structures are really useful. We use them all the time in chemistry, and they're useful because, first of all, they're easy to depict, they're easy to draw, relatively easy once we get all the rules down, and also they're accurate over 90% of the time. But they're not accurate all the time in predicting bonding within molecules, and the reason for this is because Lewis structures are not, in fact, based on quantum mechanics. So molecular orbital theory, on the other hand, is based on quantum mechanics, and specifically, MO theory is the quantum mechanical description of wave functions within molecules. So saying wave functions within molecules might sound a little confusing, but remember, we've spent a lot of time talking about wave functions within atoms, and we know how to describe that. We know that a wave function just means an atomic orbital. It's the same thing with molecules. A molecular wave function just means a molecular orbital. So we'll start today talking about the two kinds of molecular orbitals. We can talk about bonding or anti-bonding orbitals. Then we're going to actually use MO theory to describe bonding within these molecules. And we'll start with homonuclear diatomic molecules. Diatomic means it's diatomic, it's made up of two atoms, and homonuclear means that those two are the same atom. Then at the end, we'll look at an example with a heteronuclear diatomic molecule. So again, the same thing, but now two different atoms. So I will point out, in terms of MO theory, because it rigorously does take into account quantum mechanics, it starts to become complicated once we go beyond diatomic molecules. So we're going to limit our discussion in 5.11.1 for molecular orbital theory to diatomic molecules. However, on Friday, we will use a different approach so we can talk about bonding within atoms that have more than two atoms, molecules with more than two atoms. All right, so one thing that I first want to point out about MO theory that is a big difference from Lewis structures is that in MO theory, valence electrons are delocalized over the entire molecule. So when we talked about Lewis structures, we actually assigned electrons to individual atoms or to individual bonds, whereas in molecular orbital theory, what I'm telling you is instead we understand that the electrons are spread all over the molecule. They're not just associated with a single atom or a single bond. So specifically, what we do associate them instead is within molecular orbitals. And what we say is that they can be either in bonding or anti-bonding orbitals. And again, I want to point out that a molecular orbital, we can also call that a wave function. They're the same thing. And these orbitals arise from the combination of individual atomic orbitals. So if we have two atomic orbitals coming together from two different atoms, and they combine, what we end up forming is a molecular orbital. The reason that we can talk about this is, remember that we're talking about wave functions. We're talking about waves, so we can have constructive interference in which two different orbitals can constructively interfere. We can also have destructive interference.